Hi, welcome back. Right now, what we would do is we'll have a look at all of these features of Hive. We'll look at Hive data formats, creating tables, Hive managed tables, loading data into Hive, simplifying queries with views, storing query results, accessing data. Then we'll look at query performance. In query, how to improve the performance of a query. For that, there are various techniques. You might have seen in SQL, PLSQL, that you partition tables, you index tables. Then we'll also have a look at views, and we'll also have a look at various user-defined functions. I'll do a couple of them for you. Because these are purely Java-based functions. In this, what we would do is we'll create our own functions and we'll hook these functions into Hive, into the Hive framework, so that we can use it with our queries. Now, because this is very heavily Java centric, I'll be doing a couple of functions, very simple functions, and the rest for more advanced stuff, probably you can research and do a bit more. Okay. So all of these queries, all of these points that I'm going to cover, they may not be in the same order. Okay. I have mixed and matched it, and wherever possible, I've given you some hints which will optimize your queries, which will give you an idea of how to partition the table or how to bucket the table and various other concepts. Okay, so let's move on. All right. What I've as in the previous session, I have created a script file for you. Whatever commands or whatever Hive scripts I'm going to use, I'm going to paste it in this one, in this file, and I'll send this and this file will be available for you to practice later on. Okay, right. So as usual, I've been into Genie, gone into module 3. Okay, I'll just do a ls in here. So there are quite a few files which I put in there. These are data files. Okay, and these are the files that I'll use to show you a few examples. Now all these files again will be made available to you along with this presentation. Okay, so what's the first thing that I do? I get into Hive. Right. In the previous class we saw Hue and we saw HDFS name node and how data is stored. Okay, so let's get into user, Hive, and warehouse. Okay, in warehouse we created all of these tables last time, and if you look at Hue, the meta manager, the meta store manager will list out all the tables that you have, all the schema definitions that you have. Okay, so obviously it is not showing it right now, but as I said, I had a problem before, but that shouldn't stop us from doing anything else. Say show tables. Okay, now if you look at show tables, last time I showed you what's the meaning of a managed table or a self-managed table. Let's have a look at one of the tables. Say describe extended DEPT, department table. Okay, so when I did a describe extended department table, this is what I asked you to watch for. Table type is a managed table. Okay, right, and the location is under warehouse. And how did I create this table? I did a create table name, and I gave all of these uh, parameters in there. So all of these columns in there, right? So that was the location and that was the type of table. Now what we also saw was, if you look at department, and department has got department.data, right? Now when I said drop table department, what happened was, along with the department schema from the metastore says show tables, you won't have department now. If you look at this, there is no department. Now along with this schema information, the data in here was also dropped. So department doesn't exist. Now as we see that this is a major problem. Okay, so when it is a managed table, we are allowing Hive to manage the content and the schema, the data and the schema. Now this is good only when your data is temporary or you know fully well that no one else is using the data. Okay, now what happens when the data is present in a different location or this data is used by some other person? As I explained in the previous class, this data could be used by someone who is writing a MapReduce program or someone who is writing a pig program, pig Latin script. In that case, if you drop this table, all the data is deleted. So this is a issue that we need to deal with. Fortunately, Hive has provided us with something called an external table. Okay, so it is called as an external table. So let's create an external table. So I'll say now first and foremost, before I create an external table, what I would like you to do is create a folder where we will ingest this data. Okay, so I'll say in HDFS, create a folder, say -mkdir. I create a folder called books. Okay, HDFS DFS -mkdir, create a folder in this location /user/hive/data/books. So if you look at this folder now, Hive, under Hive I've created a folder called data, and under data I've created a another folder called books. Okay, so what I need to do now is I need to ingest some data under that folder called books. Okay, so if you look at this file, I've got a file called file.txt, which is again a file downloaded from Gutenberg, okay, website. So let me ingest this data. Copy from local, I'll say file 1.txt. Okay, and where do I want to copy? user/hive/data/books. Okay, I'll copy it into this location. Now let's check if this data is here. So HDFS DFS -ls /user/ so if you look at that, file.txt was listed. Now this is just a particular location inside HDFS. Okay, a location inside HDFS. Now if you go there, so that's a location inside HDFS. This is the location, right? Now what we need to do is we need to create a table. Okay, and this file.txt looks like this. So we are going to do a word count again. Okay, so what we are going to do right now is we are going to create a table and we are going to point this schema location to that particular data location. Okay, so let's do that. So let me create a table called random books. Okay, so I have the syntax here, copy, paste. Now if you look at the syntax closely, there is an extra word here called external table. Means this table, even though I've created this table, the data location is not the default location. The default location would be under warehouse. Okay, and this, the table would manage it under this folder. So right now what I'm saying is I'm creating the schema. Okay, and I'm saying, okay, this schema points to this particular location. Now this particular location has already got the data file called file.txt. So let me do that. Okay, now just to make sure, I'll say describe extended random. So if you look at that, it's an external table, and the location right now is this hive/data/books, and not like this before where it was under warehouse/department, and that was Hive managed. Okay, so let's do a little select count of from random books, random book. So obviously a map reduce job will be done, and the fields are terminated by space here. So a tab terminated, and every line will be tokenized, and those words will be counted. So it will give us a count of what the number of words that are in that particular file. So that's the file under data, under books, and that's the file. Okay, so they will be broken down like this by tokens. Okay, right. There were 2,920 words. Now what's next? Let me drop this table. Drop table random book. Okay. So when I drop the table random book, let me do this first. Show tables. So I have random book table. Okay. Now I'll say drop table random book. Now I'll do a show tables again. There is no table random book present here, but if we look at the file in the HDFS system, here the file should be present. See, the file.txt was present, so the data was not dropped. The data is still here. I'll do a refresh. The data is still here. Books, data. So this is the difference between an external table and a managed table. In a managed table, if you drop the table along with the metadata, meta information, that is the table information, along with that even the data is dropped. Whereas in an external table, because we provide the location to that external table, the data is not dropped, only the meta information is dropped. Now what is the use case? The use case, as I said, if a few people are working on same data, then you need to use external table, or if it is just temporary data, then you use managed table. So that's the difference between a external table and a managed table. Okay. Next thing that we look at is this data formats. Now what kind of data that we can ingest into Hive table. So let me just clear the screen. Okay, let's go to this notepad. Now you might have seen in MapReduce, you might have seen different file formats that you use, input formats that you use, your text input format, sequence input format, and different kinds of formats that you use. Now why do you use these formats? Because the source is in the form of a text, and this is the class that will read that text file, and this will read the binary file, key value pairs. Okay, or key value text input format. Key value input format, it's called, right? So these are the input formats. If you have done MapReduce, you would know that these are the input formats and the kind of data that they read. Okay, so in Hive also supports quite a few data formats. Now so far we have just done text files. So we have just done text files. Okay, we've ingested .txt files into HDFS, or we inserted data into Hive tables. Only the text files were the source. Okay, so these were the source. Now when you create a table, when you create a table, say example, let's create a table. Let's do the same table. Say when I say create table random books, and I said say word and string row format delimited fields terminated by say a comma or a space or anything of that sort. Now this is just half the syntax. Okay, what I have omitted here is this stored as text file. Okay, so this is the extra bit that comes into picture. Okay, so I have this table, the data inside this table is stored as a text file. Now because I've omitted that, the default is this. This is the default. Okay, so let me prove that. Okay, so let's say show tables. In this, what do we have? Describe extended words. So if you look at this table, you can see that the input was a text input format and the default was text. Okay, now Hive supports a couple of other formats as well. What are those formats? The formats are sequence files, then RC file. Okay, and it also these are the two formats, and then you have your own custom formats that you can support. Okay, so you can have a custom file format, right? So we are going to look at all three of them right now, right? And as you know, sequence files, what are sequence files for? Sequence files are for faster processing, compaction. It also gives you compaction. The serialization is faster. RC files are the best suited for Hive. Okay, and these are only compatible with Hive. You wouldn't be able to make this compatible with any other scripting like pig or something. Now sequence files, they are supported by MapReduce programming. You can do MapReduce on there. You can use pig, you can use Hive, HBase also. Okay, so all of these are supported. So and sequence files are for processing the files in a faster manner for data compaction as well. Okay, we'll have a look at all of them, right? I'll show you the syntax. So let's move on. Now I've created these scripts for you and I pasted them, but I'll go through all of them again. So say let's do that. Now if you look at this, I've deliberately named this file as nysc daily text, means I'm ingesting a text data. So I'm saying, okay, these are the fields in there. Before that, I need to show you something. I need to show you the file itself. I need to show you the data file itself before you, otherwise you'll get confused. Okay, so let's go to the file browser, module 3, and I have this data, nysc daily. Now if you look at this data, this is in the text format. The first field is the stock exchange nysc, then this is the name of the stock or the script, the date, and these all of them are, okay, this is the volume, this is the adjacent close, this is open, and in this order. Okay, let me show you that order. So exchange you have, symbol you have, date of trading, then open, high, low, close, volume. So open, high, low, close, volume, and adjacent close. Okay, so this is data that I have downloaded. Okay, and I'm using that data, right? So this data we are going to ingest in this table. Now that data is in the text format if you look at it, right? So once I do that, let me create this table, and mind you, this is just a managed table that I am doing. So everything that applies to an external table also applies to a managed table. Okay. So I've created that table. The next thing that I need to do is I need to ingest the data. How would I ingest the data? Say, because I am in the same folder as module 3, I've got this NYSE daily in there. Okay. Right. So what I do is I'll do this particular query. Paste. Now if you look at that, NYSE daily overwrite into NYSE daily text. Okay. So I've ingested this data. Let's have a look and describe this. Apologies for that. Right. So if you look at that, that's the table name. Okay. And all these columns you might have seen. Now the input format is the text input format, and the output format is also the text output format. Okay. Now lazy simple survey, which we'll look at it in a bit, and the location is this one. Okay. So Hive Warehouse NYSE daily.txt, right? Okay. Now let's get into that location. So user Hive Warehouse NYSE daily.txt. Now if you look at this file, 3.05 MB. Okay. So that's the file. Now all well and fine. You can execute query. You can do whatever you want to with this one. Now, as you are aware, sequence files are much better at compacting data. Okay. And also they are better at it offers faster serialization because of the nature of the sequence files itself, right? So let's create a table and ingest this same data as a sequence file. Now how do you do it? There are two ways to do it. First and foremost, you can take this file. Okay, I'll note it down for you. Right. So sequence file. So how do we get a sequence file? First and foremost, you can write a simple Java program to convert text files into sequence files. Okay. Now I've done that, and I've created NYSE. I wrote a little Java program and I said NYSE underscore daily dot txt. I converted into a sequence file. Okay, and the sequence file I have provided to you. Okay, I didn't give you the Java program deliberately because that's not right. So I've created a sequence file here. So NYSE daily was converted into NYSE daily sequence. So what I could do is I can do the same command, say this one. What I can do is I can two ways to do this. So sequence files you can create by converting a text file into a sequence file or using a Java program. And the second way is Hive helps us in doing this. So you run a couple of you set a couple of environment variables, and you also have a new syntax to create a table. Okay, so let's do that. Okay, I'll show you the Hive way. Now here I have the exactly the same table. Okay, so all what I've done, I'll show to you what I've done. Right here, instead of NYSE daily text, I've changed the name to seq. Okay, so all of these are the same. There is no change in there. This is the same. There is no change in there. What I'm saying is it is stored as a sequence file. So stored as a sequence file. In the previous data definition, we didn't mention anything. We didn't say stored as a sequence file. So by default it was text. So let me create this table, and this for this table the data is stored as a sequence file. Okay, so let's say describe extended NYSE underscore daily underscore sequence. Now let's have a look at this one. Now obviously the data location is by default it has created it there, but there is no data here. We have not ingested the data so far. But I want you to see this input formats. It says sequence input format and output format is Hive file sequence input format. Okay, right? So compressed is false and things like that. Okay. Now what we do next is set a couple of environment variables. So before that, I'll show you the flow. Okay. So I have a table. I have a NYSC. I got a table which is NYSC underscore daily underscore text, and here I've ingested data which is NYSC underscore daily dot txt file. Okay, so this is the data that is present in this file, in this table. So that's the table that I have. Now I created another table called NYSC underscore daily underscore sequence, and what I've said, this is a sequence table stored as sequence file. So this is the extra bit that I said. Okay, so this was table 1 and this is table 2. So I'm saying this table will read data and that data should be stored in the form of a sequence file. Okay, now what do I have to do? I have to ingest data here to this particular table, or I have to insert data in this table. So what I'm saying is there are two ways. One is write a Java program that converts this file, the text file, to sequence file, and use our command which is load data in path, give the sequence file name because this file, that sequence file name, and overwrite into table NYSC underscore daily underscore sequence. So this is one way of doing it. So you have a Java program, you create a sequence file out of it, that whatever the source is, and then take that sequence file and load it into NYSC daily sequence. Now there is another way of doing it. What's the other way? I'll show you the other way of doing it. So that was one way, and the other way of doing it. The other way of doing it is let a Hive step in between and do some magic. So what I'm going to do is I'm going to use Hive commands and environment variables to take the data from here and push it into here, okay, directly. And the conversion will happen at this place. The text to sequence conversion will happen here and the data will be pushed here. So I'm going to use Hive to get data out of a table, which is the data format for that was a text, and I'm going to push it into my sequence table. So this is what I'm going to do right now. So for that, you need to do two things. You need to set up two environment variables, which I'll tell you now. The first environment variable is I have to say compression should be set to true, and I have to use the codec. I have to say which codec I'm going to use. Okay, so those are the two environment variables that you need to set. Okay, so that is what we are doing right now. Now, as you saw that we created the sequence table, the next thing that we are going to do is set this environment variable. So hive.exec compress output is equal to true. Okay, right? And the next variable, I'm going to say, okay, use this compression codec. Use this algorithm to compress the data. So snappy codec. Okay, compression.codec is equal to, and this one comes along with Hadoop, along with Hive. Okay. So the Hadoop jar files have got this by default. Okay, so I've done that. So what's the next thing? The next thing, as I said, is to ingest data from here to here. So let's do that now. Okay. So now you will encounter a new kind of a query. Okay. So we did do load data local in path. Then that was one of the ways. The other way was we directly copied into the HDFS file system. Now let's do this. Insert, overwrite. Overwrite means rub the table clean and insert it again. Table nysc underscore daily underscore sequence. Select star from nysc underscore daily underscore txt. So select from this particular table and insert the data as it is in this table. All the conversion. So the source for this was text and the source for this is sequence. So Hive knows what to do. It will do the conversion implicitly and it will give you data in this particular table. Okay. So let's do that. So let me push enter. So here a MapReduce job will be run. Okay. Okay. And the data is in there. So let's have a look at the HDFS system. So NYSE new table sequence. The data was ported from there and that's how the data will look like. So it is all a binary. So key value pair. And how do you make out that this is a sequence file? The first line will give it away. SUQ, and that was a compression codec that was used. Rest of them you wouldn't even understand what's happening in them. Okay. So that's machine. Now you also see that the compression. Now if I look at nyscdaily.txt and this file, see it was 3.05 MB, whereas here the sequence file is 1.55 MB. So it was compressed as well. Okay. Along with compression, it also gives us faster query performance. Okay. So I've done this. We'll test all of them right at the end. But before we finish this particular topic, let's go and do another one, which is an RC file. RC file is nothing but a row. Data is stored in row and column format. Again, it is in binary format. We wouldn't be able to read it, but RC file are only for are only to be used with Hive. Okay. So again, same table syntax. The only thing that differs as before is I changed the name. I put an RC underscore RC. The rest of the columns are same, row format delimited. Now stored as an RC file. Okay. So I'll say press enter. Now I need to ingest data into this table. Now because I've already set these two variables, which is the compression and these two variables, I need not set them again. Okay. So this is available for the session. Now all I have to do is I have to run this query again. Copy. So I'll ingest data from nyscdaily.txt into RC. All that conversion happens implicitly. So let me do an enter right. So it is running its MapReduce job. We'll have a look in the browser of how the data looks like. Okay. And then we'll try and run some queries and see if we have definitely got a better and improved performance. So if I now you see NYSE daily RC, if I click that, again compression 1.24 MB, whereas for sequence it was 1.55. So it compressed more. RC nothing but row column format. The data is stored in row column format and it can be read only by Hive. Okay, and I click that. So you see RC format and snappy codec was used. Okay, so again you can't read this. Okay, so I got three tables now: text, the source was text, sequence, and RC. Okay, now since we have all these tables, let's do a describe on RC as well for completeness. So if you look at this one again, that's the folder location, but the input format is RC file input format, okay, and the output format is RC file output format, okay. So let's do a query now. Say select star from NYSE underscore daily underscore sequence, where volume should be greater than say 30,000, okay, some random query. So I've done from sequence, okay, and let's see what's the time that we get, okay. Now mind you, this is not the right environment to test the queries, okay, because uh, obviously I'm running a lot of programs on my machine, and my processor will give equal time to each and every thread that is running on this machine. Now this is inside a virtual box, okay. So this is not the right way to benchmark these tables, okay. So let's do from a text how much it takes, but the way it should work is for RC file format, the performance should be the highest. The performance of any query should be the best, means the minimum time taken should be for a RC file, okay. So here you go, it is giving some wrong reading. So again, as I said, 24.22, and also the data set is too small, okay. So let's do it for an RC one and see if there is any performance improvement. But if you have a huge cluster and a lot of data, sequence file, RC file will come first for query performance, sequence files next, and text files last, okay. That's the order. But here obviously, because this is not the right test environment, these tests, the benchmarking may not be right, okay. So let's have a look at RC now. RC is taking 24.76. Right. So that's what it was about the different input formats, okay, that Hive tables can have. What we are going to do next is we are going to look at something called as surveys. What is the meaning of a survey? So full form is serializer and deserializer, okay. So if you look at say uh, one more meta information here is this one. You see, serialization, survey info is simple lazy survey. What does this mean? It is very important, and it does do quite a lot of stuff behind the scenes, okay, right. So let me explain you what it does. What is a survey? When you did a MapReduce program, when you wrote a MapReduce program, what you did was you had an input split, and the input split had a reader internally which will read your data from the split, correct. So this it will read. Based on the number of splits, every split will feed one map, okay, and this map will do something and it will push the data forward to the reducer, okay, and this reducer will spit out data to the file system. It can be HDFS, it can be anything that wherever you want to push the data into. So this is a workflow: input split, reader, input split internally as a reader, and this will give data to a map, okay, and map will take the data, it will process the data, push it to the reducer, and then this, okay, right. So what we do in the mapper, you are also doing some kind of a whatever data has come through from the mapper, you're doing some kind of a logic on that data. Say you're doing a split on the words or something like that. Okay. So some kind of work you're doing, some kind of serialization, deserialization work you're doing. And when this data goes here, again the data goes into in a structured format to the reducer. You send a key value pair here, say a text and a text, which goes here, and the reducer takes the data, say a text and a text, does something with it and pushes it as binary to the HDFS system. Okay. So this is what happens. This is how the data flows through MapReduce. Okay. So that was quite the basics. Now the next thing what I'll do is I'll write down a couple of notes here. Okay. So what's the Hive query workflow? Okay. Now first and foremost what happens is the query optimizer or the query planner, the moment you write a query, the query planner what it will do is it will analyze the query and create a series of MapReduce job. Okay. So that is the first thing it will do. The second thing it will do is submit these jobs to the cluster or to the framework, Hadoop cluster or to the framework, so that these jobs are executed. Right. Now there are two things that can happen. One, map only job or map and reduce jobs. Okay. Now say if it's just a map job, for map jobs what will happen here is the splits will be computed, means there will be some logical logical boundaries that will be created. The data will be read, okay, by the input reader. Right. I need to put a comma there. All right. Now once the data is read, this data flows into a layer called Surday. Okay. Now because it's the map side, the deserializer will play a role. Whatever incoming data, I should say, in the form of a byte stream, okay, will be converted into a structured format. Structured format, okay, which is serializable, like the writables and all those things. Okay. So that will be converted into a structured format. So this is where the deserializer comes into picture. Now once the mapper outputs data to the reducer, the serializer plays a role on the reducer side. Okay. What does it do? It takes the structured data, okay, structured data from the map and hands it over to the output format in the form of a binary to be written. Okay. So this is where the serializer and deserializer comes into picture. Now what will be the use of a serializer and deserializer? Now we had text text data, and we had the data in a particular pattern which was comma separated or tab separated, etc. Right? Now this was read by a lazy survey, which was lazy simple survey, did the parsing for us. Okay, lazy simple survey did the parsing. Did the parsing for us. Now what if we have data in JSON format? One, either you write your survey or use something that is available. Okay, you can also have XML survey. You can have your custom survey, because your data does not conform to any of the standard formats. You also have reject survey. Okay, right? So either you write your own survey or you use something which is available. What I am going to show you is, I am going to show you a simple JSON survey, okay, which I downloaded from Google code hosting. And I am not saying this by all means this is the best survey written, but let's just do a little example to demonstrate what a survey actually means. Okay, right? So for that we need to have a look at the data. So file, let's look at this data. Now what data we are going to parse? Okay, so if you go into module 3, blog post. So this is a JSON kind of a format. Okay, so key values in there and lot of stuff in there. So that's a JSON tuple, the entire one tuple, 2 tuple, 3 tuple. So we need to parse this data. Okay, or in other words, we need to make this data available to a Hive table so that we can use SQL like queries. Okay, so what will you do? So first and foremost, let's get this data into HDFS. Okay, so let us create that folder here. Okay, so I'm created a folder called, right, so that's a folder, and I'm going to copy that blog into that location. Okay, so let's have a look at if that file is already existing. So Hive Data blog. So inside that blog we have this file now. And what we need to do is we need to create a table. Okay, let's create an external table and point to it to that particular location. Now before we do that, we need to have that survey. As I said, you create a survey. Now in this case I have downloaded a jar file which has got that survey. Now if you look at even the survey I have provided to you, so you can use this survey. So this jar file I need to make it available to Hive. So to do that I would say add jar and make it available to Hive. So make it available to this session and the mapper and the reducer and everything internally. So I have added it to my class path. So the next thing that I do is I create a table. How do I create a table? It is a little bit different. The way I create this table is I say create external table, because I already have this location. So I am going to point this schema location to that particular data location. Okay, so I'll say create block data. This one, all of this should reflect whatever fields are in there in that particular file. And here I'm saying row format survey org.hadoop.contrib.survey.json survey. Now where is this file? This file is present inside this jar, and somebody has to tell me that this is the main entry point, this is the main class for that Saturday. This is where the entry point for this particular Saturday is, okay, for this particular jar is. So if you don't have this one, it will be useless. So people, when they develop a Saturday, they will also give you the Saturday file, the main class, okay, and I'll say enter. So now it has created a file, it has created a table. It is looking at this particular location where the data we have ingested, and we are saying the data that is in there was a JSON file, and use this to parse the data. So let's do a select star from, what was it, blog data. There you go. So data more, data 1, data 2, okay. So this is how you got the data from there. So that gets us to the end of this particular session. In the next video, we'll look at more ways to optimize queries by partitioning, by bucketing tables, and further to that session, we'll look at views and indexes, okay, and the last session will be on functions. So this concludes this particular session, okay.